Up next, we're joined by Ian. Ian is a platform engineer at Arthur, where he led the effort to assess and implement Argo workflows. The team uses Argo workflows to dynamically orchestrate the data pipelines and infrastructure that powers Arthur's machine learning as a service capabilities. Ian has over 5 years of data platform engineering experience, previously at Zillow, Capital One, and Qualcomm. He holds a BS in computer science from the University of Michigan. Welcome, Ian.
Hi, everyone. My name is Ian McGraw. I'm a lead platform engineer with Arthur AI, and today I'm going to be telling you a little bit about our dynamic event-driven machine learning pipelines that we've built with Argo workflows and Go. To start the talk, I'm just going to give you a quick intro on me and a little bit about my background, and then I'm actually hoping to tell you a little bit about Arthur, the product, and sort of how we use Argo under the hood. And then would actually like to dive into our architecture with Argo and then show you a little bit about how we use it with Go to build these event-driven dynamic pipelines. So with that, a little bit about me. As you can see there in the center, I'm a Michigan grad, so go blue. If anyone else is on the call, a Michigan grad, we're having an incredible fall, so hopefully we can keep this going. Before that, I was actually from Michigan originally, and in that upper right corner, you can see a photo near my hometown in northern Michigan. You can see the lakes and the beautiful sand dunes. Definitely recommend it if anyone ever gets up there to check it out. Most recently, though, I actually live in New York City, which you can see the skyline there in the middle. And when I'm not hands-on keyboard building something, I usually like to get outside, climb rocks. I also love water sports and things like that as well. In terms of professional career, originally I was working actually at Capital One in their Center for Machine Learning, where we were working on model training infrastructure and building some machine learning APIs for customers. After that, I actually went on to Zillow. And for anyone on the call in New York City, I was actually the lead engineer for the brand StreetEasy, which a lot of New Yorkers know for apartment hunting. After that, and most recently, I've been at Arthur now for a few years, and I'm leading their data platform and engineering in that regard. So with that, I would actually like to tell you a little bit more about Arthur. And for those of you who haven't heard of Arthur, we are the AI performance company, and that means essentially anything monitoring, observation related to deploying machine learning in production. We provide a platform to do those things. And our product kind of breaks down into 3 categories. The first is performance. So we do data drift detection, we check for model accuracy, we track the performance, and we do things like logging all of your predictions and doing alerting and things like that out of the box. The second pillar then is explainability. And for people not as familiar with machine learning, explainability you can think of as a reason why a model made the prediction it did. And we'll actually show an example of that later. And then our third pillar is fairness and bias. So we provide tools both to analyze bias as well as mitigate bias in your predictions and algorithms. And so that's kind of Arthur from a high level. And today I'm actually going to be talking about one of our platform capabilities we call enrichments, which Argo is at the core of. And to start that conversation, I'd like to actually ground it with an example here. And so the way the Arthur product works is customers have models in production. Those customers are feeding data into their models and getting predictions out of their models. And then they send us both that input and that output. So as a hypothetical example here, let's take this customer data. This customer might be trying to decide if people are worthy of a loan, for example. So let's say this customer feeds in this record into their model, and their model hypothetically denies this person for credit. So the customer then would take both of these things, send them to Arthur, and then in the Arthur product, we apply machine learning on top of these data streams and add what we call enrichments. So the first example of an enrichment is an explanation. And like I said before, we think of explanations as a reason why a model made a decision it did. So in this case, we see the explanation of income is the highest, so it meant the model paid the most attention to that column. Another enrichment we do is, like I mentioned before, bias mitigation. So using statistics, we can actually analyze all of the predictions your model has made and make sure across those different groups, you're making fair predictions. So in this case, maybe we identified this record as someone who had been discriminated in the past. So we might actually change that prediction to a yes. The final example of an enrichment then is anomaly detection. And anomaly detection is a number that tells us how similar is this customer data to the data they've sent us in the past. So collectively then we call this whole bottom section Arthur enrichments. And just kind of to ground this from a high level, again, we can think of enrichments as Arthur's machine learning deployed on top of customers' machine learning. So a little bit of machine learning to monitor machine learning there, but that's an oversimplification. And customers can use these machine learning capabilities sort of as machine learning as a service. So they can say, I want anomaly detection, and push a button and get anomaly detection. All of our enrichments follow a similar pattern where something is trained, saved, and then deployed against their customer data stream. And at scale, obviously, with a lot of customers and all of our customers having a lot of models, we have a ton of data streams running in our backend, and orchestrating all of these machine learning pipelines and plugging them into those data streams is a huge, huge complex orchestration task. So this is where Argo comes into play. And we actually started down the road with Argo about a year ago. And when we first were looking for orchestrators, we evaluated three main ones. Obviously, Airflow, everyone hears about a lot. And Airflow had a number of drawbacks in this use case specifically because it's so tied to a schedule. We needed something that could be event-driven and dynamic, which Airflow did not do well. Prefect then is a little bit more in that direction, but Prefect is so heavy and runs like a variety of services on the back end that it's actually a pretty heavy application to install, which is important for us because we actually ship our product to customers so they can install it in their on-prem data centers or in their private clouds. So we need to be very cognizant of every container we ship. So Prefect was too heavy for our solution. Which then we found Argo, which ended up being a great fit because it's Kubernetes native, which so is the rest of our platform. So that was perfect. And it's a single container, so it's super lightweight. We don't have to worry about maintaining a suite of microservices on a customer on-prem deployment. One of the things we actually didn't like with Argo at first was that it was a YAML-based definition. And we spent a bit of time iterating on this because we wanted our backends to be able to communicate with Argo sort of natively. And our backend is actually all written in Go, at least our API layer is. And we realized because it's in Go, we could actually import the Argo source client libraries to manipulate those workflow objects natively. And this is sort of an unlocking point for all of us. And we realized we could then sort of do much more with workflows in a codified way. We can make them event-driven. We can assemble them dynamically. We can even unit test them. And this has all sort of been a huge, huge win for Argo in our specific use case. And if anyone's interested, I have a link to a blog post where we dive in a little bit more on the comparisons between these different orchestrators, if anyone would like to check that out. Next, I'd actually love to dive into the architecture here of how sort of Argo fits in this machine learning dynamic pipeline event-driven ecosystem we've built here. In the upper left corner, you can see a sample customer, and that customer is making a simple API call that says, I would like anomaly detection or some sort of enrichment. Our Enrichments API then receives that request and looks up information about the customer, their model, and the type of data that their model is. So for example, it could be computer vision processing images. It could be tabular. It could be NLP where it's looking at text. So it combines all that information and then on the fly constructs a workflow to stand up and train the correct algorithms for that model and that data, and then hook those deployed algorithms into that customer data pipeline and configure all the infrastructure needed and the data flow needed to make that a unified stream processing pipeline. So once that workflow is then assembled, it submits that workflow to Kubernetes, at which point, of course, Argo picks it up and starts executing it. And we can see a sort of a representation of the Argo workflow in that big hexagon on the lower left-hand side. And within that hexagon, we can see 3 different enrichment streams. Those enrichment streams, then you can see the common steps. So they validate data, they update, statuses to say things like processing. It then trains and saves the algorithm. And then there's a step in the workflow that actually calls out to deploy all of the infrastructure needed to serve that algorithm and hook it in to that data ingestion pipeline we can see sort of on the right-hand side there. So looking at the data ingestion pipeline, then we can see how those enrichments piece in and the data flows from one to the next before finally ending up in our OLAP database where customers query it, we do alerting and all of those things. One of the huge wins of using Argo and Kubernetes to do these data processing and serving data streams is we've actually been able to build a super scalable stream processing engine here. We've instrumented our Kafka cluster with metrics that report back to Prometheus about the lag of all the topics. And we've actually built an in-house custom HPA that queries Prometheus for those lag metrics and will scale up and down our enrichment processing based on the lag in those topics. And this actually goes as far as when a topic is empty, like all the data has been processed, it will shut down the enrichment completely. So we're not paying for any compute. And this has been huge because some of these enrichments are extremely compute intensive. So we've been able to save a ton of costs and optimize our infrastructure so it grows when we need it with this setup. And we've been actually really happy with it, and we're continuing to build and evolve and work with Argo. So up next, then, I'd like to show you actually a quick demo. And the source code for this demo is available publicly on GitHub. So if you're ever trying to experiment with dynamic workflows in Argo or see how to import the Argo source code into Go, feel free to check it out. Definitely would recommend it. So quick snippet of code here to show you. In this demo, I've created a chef Argo, we can think about it, where Argo can cook you a variety of meals based on what you like to eat. And the core of the source code comes down to these few functions here, where we're actually importing the Argo types for the templates and the DAGs. And you can see here the workflow itself. So this code then assembles a DAG of steps to assemble each meal and then combines those into a workflow and submits it to Argo. So I'd like to actually show you what that looks like behind the scenes now. So to invoke the script, you can just run, feed me. And then let's say I'm in the mood for steak and cake for dinner. So I'll go ahead and submit that. And then if we flip over to Argo, we see that newly created workflow. And we can see it's a little small right now, but there's 2 main branches at the beginning, one to cook my steak and one to cook my cake. And as we can see, this will evolve and those steps will finish. And let's give it a second here. So yeah, we see the steak's finished and now the cake is finishing up as well. And we can even extend this then to say, I'm hungry for a lot of things. So let's make all the meals we possibly can. So I'll go ahead and submit that as well. And we can see now we have a second workflow running. And this one's much bigger for creating all these different meals. And really, these workflows are just an example of things you can do. But, the point here is to illustrate that it's very easy to set up code to build and construct and submit these workflows to do an arbitrary number of tasks based on user demand. So this could be, standing up infrastructure, training ML pipelines, managing that infrastructure, or different things like that. So super powerful and an expressive way to use Argo almost as an API behind the scenes to implement a lot of these features that, customers would like to see in long running workflow tasks. So with that, I'd like to flip back to the slides, and I'd just like to finish up by saying, if anyone has any questions or comments, please connect. I'd love to hear from you guys. Is anyone doing something similar? Have you run into roadblocks? What have you found has worked well? Would love to connect. Feel free to hit me on LinkedIn or shoot me an email. And also just a shameless plug, we are hiring. So, engineers, business sides, sales, marketing, if anyone's interested in working on sort of the next generation of AI and the tools and the ecosystem around it, feel free to reach us out there. We'd love to speak with you. With that, thank you.